pack nomenclature for hydrocarbons. Select the longest continuous chain. Then use cyclo if it's a closed chain. Then use the prefix according to the number of carbons. Then use the suffix according to the type of bond. If it's single, ane, double, in, triple, ine, then number the chain. Alkanes and number to the closest branch, and alkenes and alkynes and number to the closest double or triple bond. UPAC nomenclature for alcohols, aldehydes, ketones, carboxylic acids, amines, and amines. The first step is to select the longest continuous chain. Then, number the main chain on the side closest to the functional group. Then, name the branches. And at the end, name the main chain with the corresponding suffix. You have to put in which carbon is the functional group in ketones and alcohols. UPAC nomenclature of esters. The shorter chain of the two chains becomes the first part of the name, in which the ane suffix is changed by oxy. The longest chain keeps its hydrocarbon name. Common nomenclature for carboxylic acids, esters, and amines. You have to put the prefix and then the suffix of the functional group. If it has one carbon, the prefix is form, 2 carbons acet, 3 carbons propion, 4 carbons butyr, 5 carbons balder, and 6 carbons carb. In case of esters, the main chain stays the same and the short chain is the one that changed, but instead of writing 8, change to 8. Common nomenclature for alcohols and amides. Pretend that the functional group is the main chain and name the carbons. Common nomenclature for ethers. The two R groups are named with two separated words, alkene in complexity order, followed by the word ether. These are some examples of each functional group.
Now, physical properties. Solubility. Hydrocarbons are insoluble in water but soluble in organic solvents. Alcohols, aldehydes, and esters. Solubility decreases as the carbon chain increases. Ketones are soluble in alcohols, ethers, and chloroform. Carboxylic acids depends on the number of atoms. Amines. Short branches are soluble in water, with longs are soluble in organic solvents. Boiling and melting points. Hydrocarbons and esters. As the number of atoms increases, melting and boiling point increases. Alcohols and ketones are far greater than their respective hydrocarbons or aldehyde. Ethers, very low. Aldehydes, intermediate boiling points. Amides, high melting and boiling points. Density. Hydrocarbons. As the number of carbon atoms increases, density increases. Ethers are denser than water. Carboxylic acid less dense than water. State of matter. Alcohols, ethers, and ketones are liquids at room temperature. Hydrocarbons. 1 to 4 carbon gas. 5 to 16 carbons liquid. 17 or more wax solid. Smell. Ethers, ketone, and ester have a nice smell. Carboxylic acids and amines have a bad smell, and hydrocarbons don't have smell.
Common uses. Alkanes are used as heating, electricity generation, paraffin wax, and production of polymers. Alkenes are used to produce plastic and polymers, energy resources, and general anesthetic. Alkynes are used as energy resources that produce high temperature flame and also as a solvent. Alcohols are used as solvents, antifreeze, and wine and liquor production. Ethers are used as solvent, explosive manufacturing, and anesthetics. Aldehydes are used to preserve anatomical parts of the human body and to give a vanilla smell in some products. Ketones are only used as solvents. Carboxylic acid are used in the manufacture of soaps, coagulant in the manufacture of rubber, preparation of drugs like aspirin, and as preservatives in food. Esters are used in scents, in perfumes and candles, synthetic fiber production, and used in soap and detergent production. Amines are used in vitamins, cosmetic and textiles, dyes, and morphine and heroin. Amides are used in the production of antimicrobial, penicillin and LSD, synthetic fibers, and disinfectant.